Good evening from Micro Live. Later in the programme, I'll be trying out some software that lets you create your own newspaper.
And we take a look at Sinclair's new micro, the 128K Spectrum.
And American reporter Freff meets Ray Kurzweil, artificial intelligence guru and inventor of this amazing musical instrument. Gotcha! But first, I'm having a go at this game. It's called Who Dares Wins 2. It's not really my style of game, but I could actually get to like this. I'm having an amazing success. I'm walking across the water. Look at this, walking straight up, oblivious to the bullets. Success could actually go to my head, I think. No, I haven't just developed a natural new talent for this sort of game. I have to own up, I'm cheating. I'm using a device that's to be launched next Monday. It's called Game Killer, and it's a cartridge that simply plugs into the back of the Commodore 64. It costs £14.95, and basically it stops you getting killed. Now, it works like this. Off he goes. These objects on the screen, you can see some of them there, the men, the bullets and the bombs, are called sprites. And in the Commodore 64, they can be moved around the screen by some special hardware. Now, normally, every time two sprites collide, it registers in a particular part of the computer's memory. But with Game Killer on, it stops it from registering. And that's why my little man seems to be completely oblivious to the hail of bullets. Whoopsie-daisy. There we go. But in fact, it's not quite as simple as that. As you saw there, I did actually get blown up by an explosion. You see, some of the sprite collisions may be detected by the software, and then Game Killer won't work. Now, in fact, in this game, my bullets collisions... Let's get it back up again. There we are. My bullets collisions are detected by the software, so I can still attack, which is great. But alas, as you saw, the explosions are too, so I can still get zapped by a bomb. So, which games can you use this on? Well, the manufacturers Robtech claim that it will work on virtually any game that uses sprite graphics. But we found that all these games here, that's including some favourites like Ghostbusters and Jet Set Willy, are either completely unaffected by it or they even crash. Now, when it does work, it means that you can get through to levels of your game that have always beaten you before. You may even discover that some of the promised levels don't exist because the programmer thought nobody would ever reach them.
Next week, how to cheat at patience. And now here's our American reporter, Freff, with a profile of a man who's leading the world in applying artificial intelligence to commercial products.
Raymond Kurzweil is a 38-year-old inventor who lives in a dream world. In his universe, there are machines that can read books to the blind, typewriters that work when you talk to them, and pianos that quite naturally turn into choirs.
Ray's about the greatest guy to work for I can imagine. He's extremely bright, and he's attracted bright people to his team here.
I listened to him, and after about 15 minutes, the only thought I had for the rest of the 2 hours that he talked was, how can I get to work for this guy? What do I have to do to join his company? He's a combination of the things that you run across very rarely in one person in this business. He's a good businessman, a visionary, a leader, and a technologist.
Kurzweil's office wall reflects both his achievements and his taste for publicity. The man himself seems very ordinary, although he's clearly impressed at least some of the right people. His passion for science is obvious, and he owns an impressive collection of famous scientific autographs. His interest in artificial intelligence, though, started when he was still in high school.
Well, I got interested in the area of pattern recognition. In high school, I did this project using computers to try to figure out what differentiates a melody we find satisfying and from a random sequence of notes. And I wrote a program that if you fed it a melody, it would create a computer model of the patterns that it found in that melody, and then would generate original melodic sequences of notes from that model. They were similar to the compositions it had analyzed. So if you fed it Chopin, it would then write more Chopin melodies. If you fed it Mozart, it would write more Mozart melodies. And if you fed it Mozart, it would then sound similar. It had everything that Mozart melodies had, except the genius of Mozart. It sounded like a third-rate student of his. That was actually my first experience with what's called pattern recognition.
And Kurzweil's success has been in applying pattern recognition to solve some difficult problems.
Thank you also for the hospitality you shared.
The Kurzweil reading machine was his first product. It's been installed mainly in libraries all over the world, for the first time giving blind people access to ordinary print. The reading machines need to be able to cope with any font or typeface, a classic artificial intelligence problem.
I think one key aspect of artificial intelligence is that it's a computer system that's interacting with the real world as opposed to some very predictable input. The reading machine for the blind is dealing with printed material that's not predictable. It'll read something that the designers of the system never even saw, and it's subject to a broad variety of real-world problems, such as ink being sprayed over the page in unpredictable ways, letters being smashed and fragmented, touching each other. One common problem, for example, in character recognition is a small E can have the loop broken and it might look like a small C. If it's in fact an E, you need to essentially mentally reconstruct the loop to add ink, even though it's not actually there on the page. And in fact, the way we approach the problem is to try to determine, well, how is it that a person knows that's really an E and not a C? One answer very often is context. A C doesn't make sense there because there's no word that makes sense if that's a C, whereas it makes perfect sense if it's an E. In fact, the character recognition system uses context. It has a complete dictionary of all of English, and it knows which letter sequences make sense and which letter sequences don't.
A more sophisticated version of the reader is the Kurzweil data entry machine, or KDEM. One of its main uses in America is in the printing industry for direct entry of typewritten copy. To ensure that data is entered accurately, the KDEM has a human operator while it learns the font. As the document is scanned, any letters the KDEM is unsure of are highlighted. It displays an enlargement of what it sees on the screen with its guess alongside. In this case, an F and an R are touching, and the machine has interpreted it as a capital G. The operator simply types the correct letters. And after 2 or 3 pages, the KDEM has learned the font and works quickly and accurately. Kurzweil Computer Products Incorporated, the company that makes both the reader and the data entry machine, was sold to the Xerox Corporation in 1980.
Why did you decide to work on a musical instrument?
Well, I have an interest in music that goes back really since my childhood. My father was a noted musician. He was conductor of the Bell Symphony and the Queen's Concert Orchestra. So I come from a musical family. I've had a long-term interest in computers, so it's kind of a natural association. I had a relationship with Stevie Wonder from the Reading Machine project because he was one of the first users of the Reading Machine. He's quite an avid fan of electronics and computers, and we had some discussions on what the ideal musical instrument would be, and the Kurzweil 250 is an attempt to create an instrument that follows the definition from Stevie Wonder of what such an ideal instrument would be like.
To digitally store all the possible sounds of a piano would require thousands of memory chips. Kurzweil's trick was to find the patterns of similarity in the sounds of different notes played at different volumes, and then store only those similarities in memory. They represent the essence of a piano.
Using the same techniques of pattern recognition applied to computer modeling of a complex instrument, we can recreate any instrument. Here's an entire string section of an orchestra. We can split the keyboard. Here's a split between the piano and an acoustic bass, so we can play both instruments simultaneously. Here's a split between many different drum sounds.
Kurzweil's latest dream is to build a voice-activated word processor with a 10,000-word vocabulary. The first problem was to develop the hardware.
A key issue is being able to do the amount of computation required. There were analyses done when we began this project, which essentially proved that it was impossible because it would take too much computation. These analyses went through an analysis of how much computer power you would need to recognize a 10,000-word vocabulary, and came up with the answer you'd need 3,000 or 4,000 computers. And then went on to say, well, computers are getting faster each year. Maybe it won't be that long before computers are 4,000 times faster than they are today. But they're only doubling in speed every couple of years or so. So in fact, it'd be well into the next century before they multiplied by 4,000. So therefore, we're going to have to wait till the next century. Well, a whole other approach is, in fact, not to do one computation at a time, but in fact to do thousands of computations simultaneously. With custom integrated circuits, it's now possible to do that at relatively low cost. We have chips that we've developed ourselves that can actually do 8 or 10 things simultaneously and do them faster than general purpose computers because they're not programmable. They can just do their operation in a dedicated way at a faster speed than a computer. So you're talking about, for several $100s worth of silicon, being able to do computation at 4,000 or 5,000 times the speed of a conventional computer.
And all that processing power is needed to find patterns in the jumble of information that is speech. These are computer representations of the same word, as said twice by the same person.
Barricade.
Now for the second one.
Barricade.
In the bottom display, you can see that the B portion of the word barricade is considerably longer than the B portion on the upper plot. This also holds for the vowel portion and the other parts of this word. The programs which do the speech recognition must not be fooled by that. We have to construct the programs so that they understand what is important difference and what is unimportant variability. That is a very difficult task.
We have 7 what we call expert systems, each of which is actually trying to determine what is the word that the person has said or is going to say, and it uses somewhat different techniques. One technique is language analysis. Based on what you've already said, what is this person likely to say next? As a person speaks, it actually parses the sentence, figures out what each word is doing in the sentence. It builds up these sort of tree-like structures that you learn in grammar school. Our system is able to actually predict which words make sense and which words don't make sense as the next word in the sentence. So before you even say the next word, it's already largely eliminated the bulk of the vocabulary as being nonsensical at that point. But they all use somewhat different techniques, and they each have different strengths and weaknesses. And then there's a master program called the Expert Manager, which has knowledge about the strengths and weaknesses of the different systems, and is able to combine the input of all these different 7 experts to come up with a final answer.
So how close are they to a working system?
Anybody who expects to be able to buy a product from us the day after tomorrow that will allow them to say anything they want as fast as they want and they never have to train it is going to be mildly disappointed. Because when our products first come out, you have to spend some time, not too much, but some time, training them to your voice, to how you sound. You have to, at first, pause briefly between each word you say, like this, rather than say a stream of words all run together the way we normally talk.
We have had a prototype working of a 10,000-word system for about 6 months. It's been running at 97% accuracy. In fact, in the 3% of the words where it doesn't get the correct choice, the alternate word, which it also displays on the screen, is almost always the correct word. So the vast majority of errors are corrected simply by hitting one error key.
The only tiny problem being that the system was taking about 2.5 minutes to recognize each word. That's improved now, although the project is still behind schedule. Already on the market is what they call the small recognizer, which has a 1,000-word vocabulary.
Okay. Zoom in. Again.
One of its first applications was this computer-aided design package. Together, they were used to design the custom chips for the big recognizer.
Draw. Tack. Draw.
Look ahead, 5, 10 years. What's going to happen?
In offices, I see speech recognition being very widely used for creating written documents, for talking to a computer in normal English without having to be trained, so that you can ask any question you want of a computer, and if it doesn't have the information in its own database, it'll actually, on its own initiative, call up by telecommunications other national databases very quickly, electronically, gather information from around the world, and give you an answer within seconds. Computers will be much more accessible in that we will not have to learn specialized skills to interact with them. They're going to move to where people are, as opposed to people having to adjust their methods of communication to be compatible with computers.
Raymond Kurzweil talking there with Freff. Now, 2 weeks ago, Sinclair announced a new micro. It's the Spectrum 128, a memory-expanded version of their best-selling, although now aging, home computer. And already, Sinclair claimed to have taken orders worth £14 million. It was launched last year in Spain, but it wasn't available in British shops because Sinclair still had vast stocks of the older 48K machine to sell. Sinclair say the new Spectrum is aimed at the so-called entertainment market. Well, that's games to you and me. But for some inexplicable reason, there isn't a joystick port to be found on it. Well, presumably Sinclair still have a vast warehouse full of Interface 2s. However, they have taken the opportunity of sorting out some of the shortcomings of the earlier machine. For instance, the old dot crawl, which caused a lot of criticism of the picture quality, has now been eliminated. And there's a new 8-pin DIN socket on the back here, providing composite video or RGB output. So now you can use a high-resolution monitor. Well, of course, you can still use a domestic TV if you like this. There's also much better sound, which now comes out of the TV speaker. Well, hardly Kurzweil, but not too bad. It uses a standard 3-channel sound chip, and already the cynics are saying that at last the Spectrum has the sound capabilities of the long-dead Auric. However, it is a big improvement on the inaudible old beep. Now, this program here is called Gladiator from Domark. It's been specially written for the 128, but prospective owners will be worried about compatibility with existing Spectrums, for which there are some 5,000 titles. We spoke to Sinclair Research, who said it was overwhelmingly compatible, but warns that some peaks and pokes may not work. Certainly the programs I've tried have worked. In fact, this is actually 2 micros in one. On power up, just reset it, it kicks off in 128 mode, as you see, and it's ready to load a tape at a single key press. But I can select the 48K mode, quite simply, like so, and there you are. As you now see, it claims to be a vintage 1982 machine. And just for old time's sake, they've even kept a few of the original bugs in the ROM. But here's something it certainly couldn't have done in 1982. It's controlling a music synthesizer through its musical instrument digital interface, or MIDI for short. As you can hear, it works fine. The MIDI socket just here also doubles as an RS-232 port, well, at least according to the label they've got here, and that means in theory you can now drive printers and modems. But, and this is pure Sinclair, this socket conforms to no known MIDI or RS-232 standard, and even though this looks like a regular telephone plug, it isn't. So, the new machine has a few new features, a few enhancements, but it's no dramatic advance on the old Spectrum. So, earlier today I asked Alison Maguire, the marketing manager at Sinclair, why they had bothered.
We bothered because we wanted to give people more features that would make the 128 a better entertainment machine and an easier machine to use for programming. And we've tripled the memory, we've vastly improved the sound, and we've added a new piece of software that makes it easier for people writing basic programs.
Such advantages as there are have got to be measured against the price, which people are saying is horrendous, £179. How do you justify that?
Before Christmas, we took the 128 out into the marketplace and we asked people several questions about it, including what they would guess the price would be. And the vast majority set the price at between £170 and £180. And don't forget, we include 2 completely free games for that, both of which sell for £9.95 each at the moment.
Why is there no joystick port, and why is the MIDI non-standard?
We thought very carefully about putting in a joystick port, but decided not to because we knew it was important that the 128 should be software compatible with the 48. There is no standard joystick interface. If we'd built one in, we would have lessened compatibility. As for the MIDI interface, we have used the same socket as we used on the QL, and it doubles as an RS-232 port.
Who's going to use it? Are people going to upgrade from their 48s, do you think?
anyone will use this computer if they want to use a computer for having fun and learning to program. I think people probably will want to upgrade from their 48, but I think most of our customers will be new users of computers, first-time users.
Does that mean the 48 is now going to bite the dust?
Not at all. We think there's a lot of life left yet in the 48K, and we'll be selling it for a long time to come.
Alison, thank you very much.
Thank you.
Next Tuesday sees the launch of Eddie Shah's new newspaper, Today, which he claims uses the most advanced printing technology in the world. This is a test copy. Both the pictures and the text are processed and assembled into pages entirely by computer. Well, it's now possible to do something similar on home micros. There are several packages available that will help you jazz up the tennis club news, perk up the parish magazine, or in our case, mutilate the microlive notes. For home publishing, you really need more than just a word processor. You need to be able to generate documents containing both text and illustrations. And you need the text to be available in a wide variety of fonts and sizes. Well, this package, PageMaker, can do all those things. It runs on a BBC Micro, and you also need a dot matrix printer to print things out. Well, you don't really need a mouse, but it makes it a lot easier. And these are the control buttons here that I shall be using to do almost everything in composing my little newsletter. Well, it lets you compose pages with many of the features you'd expect from a real newspaper. It's got headlines, it's got columns, it's got pictures and diagrams and so on, and it's all very nicely laid out. It's rather clever, I think. Well, I'm in the process of writing our microlive program notes, and you can see I've got half a page here, and that's what's displayed on the screen. I can scroll it up and see the bottom half down here eventually as I go along and prepare things. Well, I'm just going to write a new column over here, and I position the cursor where I want to start typing, and just hit one of the keys on the mouse like that, and I can type Home Publishing. There. Now, I don't want to carry on at that size of font, it's rather too large, so I'm going to change the font size by altering it like this, and I just take it back to a smaller font size. Now, the next thing I have to do is to really define where I'm going to actually put my new piece of text. Well, I want it clearly in this area under Home Publishing. So I select this icon there and go to Define, which enables me to define the area. I place a crosswise there, and all the time I'm just using the mouse. It's very straightforward, and there. So I've now defined exactly where I want my text. Well, I could type into this area, of course, but instead of doing that, what I'm going to do, I've already prepared an article using a word processing package, and I'm going to extract from that word processing package and write it in that space. This helps you, for example, if someone else has actually sent you an article that you want to use on his micro. So the next thing I'm going to do is to go in there and read a file. And it's asking which drive. It's on drive 0. And the word processing package I've used is called View. And it's asking me the file name. So I've got to change the disk here. And this is the disk that I've already prepared using View. Stick it in there. And the file name is Home. Now what it's asking me to do is to position the cursor where I want this to be printed. And I want it just in there. And away it goes. Now, I've used all the facilities of the word processing package to produce this, but this package is actually spacing it out and opening up the words so I don't get split words at the end of a line, and it fits perfectly into the little area that I've actually allocated to do it. And it's rather nice, and that's it completed. Now, the next thing I might want to do, there's an article on page 3 on the Sinclair spectrum, so what I'm going to do is to actually try and draw a Sinclair spectrum in the area that I've allocated for it here. And to do that, I select this icon here, which is a kind of paint pot. And I go into Shapes, and of course the shape of a Sinclair spectrum is a box. And quite rapidly, I can try and draw myself a Sinclair spectrum. Well, that's one box, and of course it's got keys on it. And so I start off doing the keys like this, and I can repeat them. There we go. Repeat them like that, and so on and so forth, and get some sort of replication of a Sinclair spectrum. Now, I might want to actually colour that in or paint it, so I go to the paint icon up here and take it down here, and bingo, I've got something black, and it roughly looks like a Sinclair spectrum. Well, it doesn't look very good to me. It's rather pathetic. But what we'd like to do now is to load in a real picture of a Sinclair spectrum. Lesley.
Right, and this is how we're going to do it. We're going to use this device from Watford Electronics. It's called a digitizer. It costs £95 and it lets you grab frames of video into your micro. Now, I've got the digitizer connected to an ordinary home video recorder, and you can see the television there is tuned to BBC One. Who have we got on? The Terry Wogan Show. His guest is Norman Tebbit. I'm sure neither of them will mind helping us with this demonstration. Right, now what happens is once every couple of seconds or so, the digitizer scans the incoming pictures, sending the video information to the computer's memory, and you can actually see that happening on the computer monitor. Now, seriously, we must say at this moment, if you're going to publish pictures taken off the television, you do need copyright clearance from the broadcasting company. But, of course, you don't have to use broadcast pictures at all. You can also use a home video camera, like this one here, and you can grab pictures of anything, your husband, your granny or your dog. But what Max said he wanted was a picture of the spectrum. So that's what he's going to get. I shall select camera on the video, and as soon as I've got a picture of the spectrum up on the computer monitor, it means that that's safely in the memory, so I should be able to save that picture onto disk. There it goes. Yep. And, of course, once I've got it on disk, I can do anything I like with it. Mac, I believe you wanted this for your Micro Live publication?
Thank you very much.
Hold
Here
the
we
front
go.
page.
Let's try it. Well, I've already scrolled up, as you can see, the top part of the page, and I've got to, by using this arrow here, I just scroll it up a little bit more to give me the whole of the bottom half of my sheet. And there it is. Now, what I've got to is to, of course, read in the disc that Lesley has just given me. And I'm going to read it out onto the screen, insert the disc and press execute. Here we go. Drive 0. Load. And it's asked me the file name. Now, this file name this time is Spectrum. It looks an odd spelling, but that's the name we've given to the file. And here's hoping, Lesley, that you got it. It is, perfectly. And here it is beginning to come out. Now, it's a very hard test for the digitizer, is this, because the spectrum is black with black keys with this very fine white lettering on it. And you'll notice that it's also negative. In other words, it's like a negative film you've got processed in. The black is white and the white is black. But once it's in the machine, we can do all sorts of things. We can turn it round, left to right. We can flip it over, top to bottom. We can increase its size to double the size. We can shrink it down to half the size, to position it in any particular position we want in our newspaper. And we can also actually touch it up by using the paintbrush and clear out some of the mess that we've got. Well, there it is. It's read in. Now, let's take the icon down to there, and we can invert it, and bang, that's our picture of the spectrum. Well, it doesn't look all that brilliant, so perhaps what we should do is just do a little bit of a touch-up. And I can do that by, again, selecting the paint pot. I want a pattern. The pattern I'm going to select is white, because I'm going to clear up some of those terrible dots and things. And I'm going to use the spray to do that. And start, and there we go. I'll start to clear off all this rubbish around here. And oops, I've carved out a bit of this wonderful spectrum. And so it goes on, and that's really quite nice. Well, the PageMaker costs about £50. And if you want the mouse, that's another £40. You've been able to do this kind of thing for some time on more expensive equipment, but now that many home micros have high-resolution graphics and more memory, this kind of program should be soon available for a wider range of machines.
Well, that's just about all we've got time for this week. Next week, though, we talk to Shirley Williams about the way computers are affecting our working lives, and we'll be mocking up a possible office of the future. So, until then, goodbye.